Be finishing our lessons on quadratic applications by looking at area. So let's look at problem number 1. Mr. Nader wishes to construct a rectangular garden using the school as one of the sides. The other 3 sides will be constructed out of 80 meters of fencing. He can make his garden a variety of shapes, long and thin, short and fat, square, or any shape in between. We want to determine which rectangular shape will give him the maximum area. So let's start off by drawing a diagram. So we know that the school is going to be one of the sides. So let's call this is the school. And then we're going to make 3 other sides out of fencing. So here's the rectangular garden. Let's label this. So we're going to call this is our W for width, L for length. And we're just going to say that our W, our width, is going to be equal to X. So this is X right here, which means this is another X right here, because of course they're the same, because it's a rectangle. Now we know that we have 80 meters total of fencing, which means the 3 of these together must add up to give us 80. So if we add together these 3 sides, we have X plus L equals 80, which is X plus X, 2X, plus L equals 80. And now let's get an expression for L. So we want to figure out what L is equal to. So we're going to get L by itself by subtracting 2X from both sides. So we know that L is the same thing as 80 minus 2X. So we know W is equal to X, L is equal to 80 minus 2X, because we know that altogether these 3 should add up to give us 80. Now we're ready to write an equation to find the maximum area. So if we're trying to find an equation for area, what we're going to do is we want to multiply our 2 sides together, right? Area of a rectangle is the length times width. So if we're multiplying these 2 sides together, we're going to have X times 80 minus 2X, and this is going to be the equation that I'm going to now plug into my calculator. So before we graph it, let's label this. So our X is, in this case, our X represents our width, the W, and it's being measured in meters. And our Y is the area, which don't forget for your units, area is going to be meters squared because it's area. Now let's go ahead and put this into our calculator. If you haven't already, I'm going to clear off the memory, second plus 712, just to make sure I'm starting off. Once I've cleared off my memory, now I'm going to go to Y equals, and I'm going to type in this equation. So I have Y equals X, parentheses, 80 minus 2X, close parentheses. And now I'm going to go to my window. So just like before, no negatives. My width can't be negative, so I'm going to make this 0 to 10 on my X's, 0 to 10 on my Y's. Let's graph it and see if we can see our function. We can't. It's too small. So I'm going to go back to my window, and now I'm going to change it to 0 to 100. And 0 to 100, graph it again. So this time my X's are big enough, my Y's are not. So I'm going to go back to my window and change my Y. I want my Y max to be 1000 now. And great, so now I can see my entire function. I could maybe make my X's actually a little bit smaller. So instead of going from 0 to 100, let's say I go from 0 to 50. And I'm going to have my X scale be 10, so I'm going up by 10. For my 1000, I'm going to have my Y scale go up by 200. And so now this gives me a nice graph that I can graph very accurately. So this is going up by 10, 20, 30, 40. And it's going to stop at the 40. This is going up by 200, 400. 600, 800 to 1000. I know it's going to go up and then back down. And just like what we have been doing, we're going to find the maximum. We're going to find our 0. So max, second calc 4, left bound, right bound. We should get a maximum of 20, 800. Same thing for our 0, second calc 0, to the left of the 0, enter, to the right of the 0, enter. we should get a 0 of 40 comma 0. And we can now use these to answer the rest of our question. So domain goes from 0 to 40. Our range goes from 0 to 800 brackets. What is the maximum area? Area is our y, so we're looking for our y value. It's going to be 800. Look at your units, meters squared. And then what are the dimensions? So this one's a little bit different than what we were doing before. The dimensions are, we need to figure out both our width and our length. So our width is just equal to our x, which we're looking for our max. So our x value here is 20 meters. Our length, we're going to use this that we found earlier, this equation right here. So we know length is equal to 80 minus 2x. I know that my x is 20, so I'm just going to plug in 20 for my x, and that's going to give me my value for length, which in this case is 40 meters. So these are both measured in meters, so my dimensions are 20 and 40. Okay, let's move on to problem number 2. So for number 2, suppose Mr. Nature decided to place the garden away from the school where he would have to build all 4 sides. If he still has only 80 meters of fencing, how big can he make the pen? So now we have all 4 sides. And it's not against the school anymore, so we're going to use this 80 meters of fencing to build all sides. So we know that in this case, our width is still x, but this time we're going to have 2 lengths. So to solve for L, our equation is going to be slightly different. All 4 of these added together is going to give us 80. So we're adding together, you're going to have 2 x's and 2 l's that together add up to give you 80, because you need to use this 80 meters to create all 4 sides. So again, we're going to solve for L, minus 2x from both sides. This one's a little different now because we have 2L here. How do we get L by itself? We got to divide by 2. So when you divide by 2, this gives us L is equal to, make sure you're dividing both of these numbers by 2. So 80 divided by 2 gives you 40. 2 divided by 2 cancels out to give you x. So this is what your L is. It's 40 minus x. This is my length. Once I have my width and my length, again, you're looking for area. So area is, you multiply your width and length together. So x times 40 minus x. And this is the function that I'm graphing. So again, x is my width, still measured in meters. Y is my area, measured in meters squared. We're going to go back to our graph and to our y equals, and we're going to type in x 40 minus x. So right now we can, because this is the same as one we just did, very, very similar, let's just leave the windows the same, and it works pretty well, so we can use this to draw another picture. So we're still going up to 40 on my x's, but it goes a little bit lower. Just like before, find your max, find your 0. So max. Your max should be a value of 2400, and your 0 is 40, 0. So your domain is 0 to 40, range 0 to 400. What is the maximum area that can be enclosed? Areas are y, we're looking for a y value, it's 400 units meters squared. Dimensions, so again we're going to have to find our width and our length. So our width in this case is still x. What is our x value? 20 meters. Our length is now 40 minus x. We're going to plug in our x is 20, so 40 minus 20, which gives us 20 meters as well. So in this case, the dimensions are 20 by 20.